AC machines, three-phase induction motors. Objectives: comparison between synchronous motors and induction motors, and also advantages and disadvantages of synchronous motors and applications of synchronous motors. Applications of synchronous motors. Now, comparison between synchronous motor and induction motor. For a given frequency, the synchronous motor runs at a constant average speed, whatever the load, while the speed of an induction motor falls somewhat with increase in load. The synchronous motor can be operated over a wide range of power factor, both lagging and leading. But induction motor always runs with a lagging power factor, which may become very low at light loads. A synchronous motor is inherently not self-starting. So, synchronous motor is not self-starting. And induction motor is a self-starting. Next, the changes in applied voltage do not affect synchronous motor torque as much as the effect induction motor. The breakdown torque of a synchronous motor is directly proportional to the applied voltage, that is, torque is proportional to V. Whereas that of an induction motor depends on the square of this voltage, that is, torque is proportional to V square. So what's saying here, in this case, here torque is in synchronous motor very important note. Here the breakdown torque here the torque in a synchronous motor applied voltage is T is proportional to V. In induction motor torque is proportional to V square. That is the difference. It is the difference. So comparison. Here the DC. A DC excitation is required by synchronous motor but not by the induction motor. Synchronous motors are usually more costly and complicated than induction motors. But they are particularly attractive for lower speed drives because their power factor can always be adjusted to unity. And their efficiency is high. However, induction motors are excellent for speeds above 600 rpm. Synchronous motors can be run at ultra low speeds by using high power electronics converters, which generates very low frequency next. Such motors of 10 megawatts range are used for driving crushers, rotary kilnesses and variable speed ball mills, etc. Now we are going for the advantages. So synchronous motor have any advantages? So some more points we will discuss here. So advantages. The first one is the power factor can be controlled easily. The motor can work at lagging unity and leading power factor. The speed is constant for synchronous motor and it is independent of the load. So here disadvantages. It is not self-starting and it needs some arrangement starting and synchronizing the motor. It requires separate DC excitation. Initially, cost is very high. It can not be used for variable speed applications. If the motor is overloaded, it may fall out of synchronism and stop. It has a tendency to hunt. Applications. Synchronous motors find extensive applications for the following classes of service. It is used for the application power factor correction, constant speed, constant load drives, voltage regulation, here the power factor correction overexcited synchronous motors having leading power factor are widely used for improving power factor of the power systems, which imply a large number of induction motors and other devices having lagging power factor such as welders and fluorescent lights. So constant speed and load drives. Because of their high efficiency and high speed, synchronous motors are well suited for loads where constant speed is required, such as centrifugal pumps. Belt driven reciprocating compressors, blowers, line shafts, rubber and paper mills, etc. Here low speed synchronous motors below 600 rpm are used for drives such as centrifugal and screw type pumps, ball and tube mills, vacuum pumps, chippers, and metal rolling mills, etc. Now, voltage regulation. The voltage at the end of a long transmission line varies greatly. That means changes greatly. especially when large inductive loads are present. When an inductive load is disconnected, suddenly voltage tends to rise considerable above its normal value because of the line capacitance. By installing a synchronous motor with a field regulator, this voltage rise can be controlled. When line voltage decreases due to inductive load, motor excitation is increased, thereby rising its power factor, which components which compensates for the line drop. If, on the other hand, line voltage rises due to line capacitive effective, motor excitation is decreased, thereby making its power factor lagging, which helps to maintain the line voltage at its normal value. Voltage regulation. If, on the other hand, the line voltage rises due to line capacitive effect, motor excitation is decreased, thereby making its power factor lagging, which helps to maintain the line voltage at its normal value. At its normal value. Summary: we have discussed the following: comparison between synchronous motor and induction motor, advantages, disadvantages, and applications. Thank you.